We're continuing our lesson in 6.2 about simplifying radical expressions by multiplying and dividing. Okay, here we have to multiply a couple of radical expressions and then simplify the answer. So if we multiply 72 times 10, we get 720. Combining x cubed and x, we get x to the fourth. X or y squared and y cubed is y to the fifth. So there it is multiplied, but we have to put it in simplest form, which means we have to factor and simplify. So 720 is 72 times 10. 72 is 8 times 9. 10 is 2 times 5. 9 is 3 times 3. 8 is 2 times 4. 4 is 2 times 2. So there it is all factored. Since our index here is an unwritten 2, we're looking for groups of 2. So we have two 2's here. So that's going to give us a 2 outside the radical. We have a group of 2's here. That'll give us another 2 outside the radical. We have a group of 3's here. And then we have this 5 that doesn't have a partner, so it's got to stay inside the radical. With the x's, we're going to take x to the fourth, divide that exponent by the index. 4 divided by 2 is 2. It goes exactly 2 times, so we have x squared on the outside, or 2 groups of x. And then the 5 divided by 2, it does not go evenly, so 2 goes into 5 2 times. 2 times 2 is 4. Subtracting gives us 1 left over, so this 2 will be our exponent on the outside. This 1 is our remainder, so that's the exponent on the inside. So we have y squared on the outside, y to the first power on the inside. Combining the 2's and the 3, 2 times 2 times 3 is 12. X squared, square root 5y. This is simplified form. Okay, next example. We will multiply 45 times 35. That gives us 1,575. So we're just multiplying our radicals together here. And then x to the fifth times x gives us x to the sixth. Y cubed times y to the fourth gives us y to the seventh. Okay, so there it is multiplied, but we still have to put it in simplest form, so we have to factor. 1575 we know is 45 times 35. 45 is 9 times 5. 35 is 5 times 7. And 9 is 3 times 3. So we have a group of 3's, a group of 5's, and a 7 left over. With the x's, we're going to divide by our index, which is 2. 6 divided by 2 gives us x cubed. 7 divided by 2 is going to give us 3 with 1 left over. So that's a y cubed on the outside, y to the first on the inside. Multiplying on the outside, we get 15x cubed y cubed times square root of 7y. There's our simplified answer. Okay, we can use the same pattern for division. So if we have two radicals with matching indices and we're doing division, we can put them under the same radical as long as b is not equal to 0. For example, the square root of 18x to the fifth divided by the square root of 2x cubed can be rewritten into one radical, 18x to the fifth divided by 2x cubed. Since they're in the same radical, then we can simplify just by dividing in here. 18 divided by 2 is 9, and simplifying x to the fifth divided by x cubed is going to be x squared. What we have is 5x's here over 3x's. So 3x's will cancel. You're left with 2x's. That's the x squared. Now we still have to simplify this after we have divided. So the square root of 9 is 3, and the square root of x squared is x. In our second example, we're going to do the division first. So the cube root of 162 divided by 3 is going to be 54. Y to the fifth divided by y squared, subtracting exponents leaves us with y cubed. We still have to simplify this, so we're going to factor the 54. 54 is 6 times 9. 6 is 2 times 3. 9 is 3 times 3. We're looking for groups of 3 because it's a cube root. So we have one group of 3 and a 2 left over. With the y's, we have the cube root of y cubed, so that's just going to be y to the first power on the outside with nothing left over, and that's our simplified answer. Okay, last example here. One rule that I haven't mentioned before is that when you simplify a radical, you are not allowed to leave radicals in the denominator. So we're going to simplify this radical so that when we get done, there will still be a radical in the numerator, but the denominator will not have a radical. So first thing I'll do is factor the 12. So 12 factors is 4 times 3, and 4 is 2 times 2. So as we can see here, we don't have any perfect cubes in the denominator. So let me rewrite it. We have 5x squared on top. We have 2 squared on the bottom times 3. And then we have y squared and z. Okay, we cannot leave the radical in the denominator, so what we'll have to do is multiply this fraction times equivalent fractions that equal 1 so that we can get rid of all the radical notation. So for example, if I multiply this denominator times the square root of 2, the 2 squared and this additional 2 will give me 3 2's. So then it's a perfect cube and it doesn't have to go in the radical anymore. With the 3's, I have 1 3 here. So in order to get a total of 3 3's, I'm going to have to multiply by 3 squared. So if I multiply 3 squared times 3, that gives me 3 cubed. The cube root of 3 cubed is 3, no more radical. Same thing with the y's. I have 2 y's here. If I had one more, I'd have a perfect cube. And with the z's, I have 1 z. If I had 2 more, I'd have a perfect cube. Okay? So that takes care of the denominator. Anything you do in the denominator, you must do in the numerator exactly the same. If we do it exactly the same, in effect what we're doing is just multiplying by 1, and so we still have an equivalent fraction. So in the denominator, if I combine the 2's, I have one perfect group of 3's, so I can come out of the radical. With the 3's, if I combine those, I get one perfect group of 3. Same thing for the y's, same thing for the z's. So there's my denominator with no radical. Then in the numerator, I just have to combine all these pieces. Oh, one thing I forgot, these are cube roots. There we go. So combining all the pieces, because there are no groups of 3 in the numerator anywhere, so we just have to combine everything. 5 times 2 is 10. 3 squared is 9. So 10 times 9 is 90. I still have cube root of 90 in the numerator. With the variables, you put them in alphabetical order, so I have x squared, a y, and a z squared. This is simplified form. I know it doesn't look any simpler, but by definition, it is simpler. And we should combine the 2 and the 3 here to give us 6. You're not allowed to have radicals in the denominator. And that concludes lesson 6-2.